A very good evening, viewers. We'll be doing cation analysis for group 4 of cations today. The cations belonging to this category are cobalt ions, nickel ions, manganese ions and zinc ions. Out of these 4, these 3 are colored salts, while zinc is always a white salt. So if you've got a white salt, don't make a blunder of reporting it to be nickel, cobalt or manganese. While if you have colored salts, don't make a blunder of reporting it to be zinc. Manganese salt generally are baby pink in color, too light. So you can only identify the pink color if you compare the salt with a white tile. Otherwise, it may seem white to you. The procedure to be followed is, we begin with the OS, the original solution. To the original solution, you first add ammonium chloride solid, a pinch of it, shake it to dissolve. Now add ammonium hydroxide aqueous to make the medium basic, followed by H2S gas. This H2S gas may be added through the KIPS apparatus in your lab, or it could be a solution of sulfide ions which your teacher may be providing. Any of the two can be used. You end up in a PPT. The formation of a PPT at this stage indicates the presence of any one of these 4 cations. Hence, the group reagent for this particular 4th group is ammonium chloride, ammonium hydroxide, followed by H2S gas. The PPT that you get in this category are 3. One is a dirty white, which is zinc sulfide. Second is a buff PPT, which is pinkish peach in color, is due to the formation of MNS, manganese sulfide. And third is a black PPT, which could be due to cobalt sulfide or nickel sulfide. These two are not identifiable at this stage. If you get a dirty white PPT, how do you proceed? You add dilute HCl to the PPT and the PPT dissolves. The dissolution of the PPT is indicative of the formation of zinc chloride. To this solution, you need to divide it into 2 parts. To the first part, add NaOH solution. You will get a white PPT of zinc hydroxide. In case you continue adding NaOH solution to it, the PPT would dissolve due to the formation of sodium zincate. To the second part, you add potassium ferrocyanide solution and you end up in a white PPT in blue-green solution. The formula of the PPT would be zinc combining with ferrocyanide, valency of zinc 2, valency of ferrocyanide 4. Interchanging the 2, you get a 4 here and a 2 here, which cancels, leading to a 2 here. So the formula of this final PPT formed would be as this. Moving on to the buff PPT. But this would happen only if the salt was slightly colored. Once you get the buff PPT, you need to again add dilute HCl to it. The PPT dissolves. Once the PPT dissolves, You then need to add NaOH to it. You would find a white PPT reappearing. This white PPT would be manganese hydroxide. Leave it for some time. It takes the oxygen from the air, that is, undergoes aerial oxidation to form another oxidized product which is brown in color. So on leaving, you will find that the white PPT is changing to brown colored PPT. In case you get a black PPT in the initial stages, you need to add aqua regia to it. 1 to 2 ml aqua regia. What is aqua regia? It is 3:1 ratio of concentrated HCl is to concentrated nitric acid. You can make it yourself in a test tube. Take around 1 ml of concentrated nitric acid to add 3 times concentrated HCl. Now from this solution, add 1 to 2 ml to the black PPT and heat it for a long duration till dryness, almost dry. You will find the PPT has dissolved. Let it cool for some time and then add around 2 to 3 ml water to it. After the addition of water, the solution that you are going to get needs to be divided into 2 parts. To the first part, add 1 ml amyl alcohol and a few crystals of ammonium thiocyanide. You need to shake it for some time and you would observe blue colored alcohol layer. Since this alcohol is not soluble, so you will get a blue colored alcohol layer and that confirms cobalt. Whereas to the second part, obtained after dryness, if this happens, there's no need to move to the second part. To the second part, you need to add 4 to 5 drops of DMG. This DMG stands for dimethyl glyoxime solution, followed by ammonium hydroxide solution, approximately 1 ml to make the medium basic. You would end up in red rose coloration, which is a peculiar test for nickel. A red rose coloration with DMG is represented in a short form as this, confirming nickel. That's the test. Thank you.